This is a video presentation of Chapter 3, Section 5 in the 7th grade note-taking guide, Solving Equations Containing Decimals. Okay, so now even though we've ratcheted this up, we've gone from just positive numbers to integers, and now here's decimals. That doesn't change any of the techniques we've used. We know that so far, every time we've solved an equation that's one step, we've put our variables on the left. And remember, when I'm talking about sides at any one given point in time, that would all be relative to the equal sign. So when I say to the left, that means the variable should be on the left side of the equal sign. Second step said numbers to the right. Any lonesome numbers have to get shifted over to the right side of the equal sign. We are able to flip the sides at any one time we need to. Generally, we want to do that when the problem is presented to us initially with the variable on the wrong side being the right side. And then the fourth step says opposite side, do the opposite, which means whenever I want to move something to the opposite side individually, I want to do the opposite to get it there. So if there's subtraction in front of it, the opposite to get it there is going to be to add, and so on down the line we go. So let's go ahead and take a look at number 1 here. Now again, these questions don't really look any different than any other questions we've done because they're not. The only thing that is remotely different about these is that these are decimals instead of just plain old numbers, things we would see on the number line. So if we look at A, we've got n minus 2.75 equals 8.3. Well, rule 1 says keep that variable on the left. So n being on the left side is a good thing. And rule 2 says numbers on the right. So 8.3 being on the right is a good thing. But 2.75, on the other hand, that's a number and it's on the left. But I just got done telling you that numbers belong on the right. So we're going to go ahead and move 2.75 over to the other side. Well, if we look at it as it's presented in the question, it's got a subtraction sign in front of it. So when I want to talk about doing the opposite, that's going to mean that I'm going to have to add 2.75. And remember, when we do something, we do it to both sides of the equal sign. It's the same concept as keeping a double beam balanced scale balanced. So on the left side, that minus 2.75 plus 2.75, those cancel each other out and just leave me my variable n. On the right side, I've got 8.3 and 2.75 going together for 11.05, and that's my final answer. 11.05 minus 2.75 is 8.3 here on the left. Since the other side says 8.3, we can also see that our answer would check. Let's look at B. A plus 32.66 equals 42. So keep the variables on the left and the numbers on the right. So variable A being on the left side is a good thing. Number 42 being on the right side is a good thing. 32.66, however, is a number and it's on the left, but it belongs on the right. So we're going to have to fix 32.66. Now, if we take a look at that 32.66, it's got addition in front of it. So when I say to you opposite side, do the opposite, that means I'm going to subtract. Because that's got addition in front of it, the opposite is subtract. So I'm taking 32.66 off both sides. Over here, the plus 32.66 minus 32.66 washes each other out and leaves me variable A. Here's 42 minus 32.66, which is 9.34. And again, we can check it. Change A back into our answer. 9.34 plus 32.66 is 42. Since the other side says 42, the whole thing checks. Okay, so we go from addition and subtraction questions now to multiplication and division questions. Here's x divided by 4.8 equals 5.4. So again, step 1 says variables on the left. Well, variable x is on the left side, so that's good. And it would say numbers on the right. Well, as you can see, 5.4 is on the right side, so that's also good. So the one thing that's wrong about this is 4.8. 4.8 we're going to have to fix. Well, right now it says I'm dividing by 4.8. So to fix that, I'm going to have to do the opposite, which is to multiply by 4.8. Remember, when we show multiplying, we don't come underneath and write x 4.8, because xa, in this question, it even proves what we usually say, is my variable. So what does x mean? All right, well, we're talking x multiplication, but might it mean the variable? Yes, it might. So we don't do that. What we do is we show we're multiplying both sides by 4.8 using these parentheses. And this divide by 4.8 multiplied by 4.8 cancels each other out, leaving me 1. And then, of course, the x there, 1 times x would just be a single x, or x. And on the right side, 5.4 times 4.8 is 25.92. We can check this. 25.92 divided by 4.8 is 5.4. Since the other side says 5.4, the whole thing checks. Okay, here's the B part of that same question. 9 equals 3.6 times D. Now, you know just looking at this question that this question is going to bother me. Why? Because the variable is on the right side. But I've been teaching you all along that the variable should be on the left side. So what we want to do is go ahead and flip this equation around. It's the first time I've been able to use this rule in this presentation, not the first time we've ever used it, just in this presentation. So I'm going to invert my left and my right side and rewrite this as 3.6 times D equals 9. Okay, so we want to keep those variables on the left and numbers on the right. So the variable D being on the left side is a good thing, and number 9 being on the right is a good thing. Remember, if we looked at that question as it was originally presented, the only thing that was good about that question was 3.6. Okay, so now we know we need to get rid of 3.6 because it's a number and it belongs on the right side. Well, right now this says I'm multiplying by 3.6. And the reason that's important is because remember, when we move something to the opposite side, to do that we do the opposite. So the opposite is going to be to divide by 3.6, which is still what they're showing you here in this backwards solve method that they've used. 3.6 divided by 3.6 knocks each other out and leaves me D. And 9 divided by 3.6 is going to be my final answer, which is 2.5. We can check it. 3.6 times 2.5 is 9, since the other side of the equal sign says 9 as well. All right, let's go ahead and our story problem that's presented to us
here. It says a board game box is 2.5 inches tall. A toy store has shelving space measuring 15 inches vertically in which to store the boxes. How many boxes can be stacked in the space? So the first thing they've done is they've gone and highlighted the important information there. That each board game box is 2.5 inches tall and the store has shelving space measuring 15 inches. Then they set up a plan. The total height of the boxes is equal to the height of one box times the number of boxes. And since we know how tall the shelf is, you can write an equation with B being the number of boxes. Let's think through this for a minute. If we had one box on the shelf, we know that would take up 2.5 inches of space. What did we do? Well, we did 2.5 times 1. If we had 2 boxes on the shelf, we know that would take up 5 inches of space. What did we do? 2.5 times 2. If I had 3 boxes on the shelf, I know that would take up 7.5 inches of space. Why? What did I do? 2.5 times 3. I'm taking 2.5 the height and multiplying it by how many boxes there are. I don't know how many boxes there are, though, in this question. So that's why they're saying 2.5 times B. Remember, the variable always represents what we don't know. What we don't know is how many boxes there are. But what we do know is whatever that is the same as 15 inches. Because that's what they say at the start of the second line of material there, that there's 15 inches of space. And that's how this ends up being an equation, because an equation, of course, states that two things are equal. 2.5 times the number of boxes equals 15, as presented in the question.